Okay, so the topic for today is periodic table. And for every paper, whether it's MCQ paper or structured paper, they will provide you with the periodic table. So you need not have to by heart the elements, where is the position of the elements, so do not get panic about it. So now when we look at the periodic table, so this will be something which will be given to you at the end of the paper. Now, when you see the periodic table, now it is like a blocks. Now, these blocks are nothing but your periodic table is divided into vertical columns, which are called as groups, and horizontal rows, which are called as periods. So some characteristics of periodic table we will learn first. So vertical columns are called as groups. So there are total 18 groups in the periodic table. Vertical column calls that groups, 18 groups in the periodic table. And we have horizontal rows, which are called as periods. And there are in total 7 periods. So vertical columns, which are called as groups, horizontal rows, which are called as periods. So let us just number the period. So this is period 1, 2, 3, 4, 5, 6, 7. This is a part of period 6. Okay, this is a part of period 6. It's not a different period. And this is a part of period 7. Okay, this is a part of period 6, and the later one is the part of period 7. So it's not a different period. Then talking about the vertical columns, which are 18 vertical columns. So starting with 1 from here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So vertical columns. Now these 18 groups are classified into, okay, let me write these groups, about the groups, in the next slide. Okay. So talking about the groups, that is vertical columns, okay, groups, the 18 groups. The groups are classified into A group elements, A group, which are called as normal elements. Okay, A group elements, which are called as normal elements. And we have something also called as B group elements, which are called as transition elements. So A group elements, and we have B group elements. Now, A group elements are which groups? So they are group 1, group 2, and group 13 to group 18. So if we look back to the periodic table, so this group 3 to group 12, are the B group elements, and they are also called as transition elements. They are also called as transition elements. So this group 1, group 2, group 13, 14, 15, 16, 17, and 18, they all are A group elements. So when you look at the periodic table very keenly, group 1 is also denoted as Roman number 1A. Group 2 denoted as Roman number 2A, because they are being classified as A group element. And group B, which is transition elements, it is right from group 3 to group 12. So is this group thing clear? Okay, is this group thing clear? Yes? Can we go ahead?
Yes.
Yes,
Okay.
Miss.
Now we will study individually about certain groups. We are not going to study about all the A group elements. So we are going to study certain groups, that is specifically group 1, group 17 and group 18. So those properties we are going to study. So talking about group 1, okay, when we talk about group 1 or 1A, group 1 or 1A are called as alkali metals. Group 1 or 1A are called as alkali metals. As I told you that you will be provided with periodic tables, so I'm just jotting down the elements of group 1A. So group 1A means vertical first column you are talking about. So starting with lithium, sodium, potassium, rubidium, cesium, and francium. Okay, lithium, sodium, potassium, rubidium, cesium, and francium. Now, what is the peculiarity about this group? So one more common characteristic of group. So when we talk about A group elements, okay, I'm talking about A group elements. Now in A group elements, the group number will denote number of valence electron present in an atom. Valence electron means talking about the outermost electron. So if I say that my element belongs to group 1, so the valence electron will be 1. So over here, if it's lithium, it belongs to group 1. So number of valence electron will be 1 and valency will be +1. That's basically it will lose electron. If it is group 2, valence electron 2, valency will be +2. Now we will not be going to group 3 to 12. Why we will not go to group 3 to group 12? What's the reason? Why we will not consider group 3 and to group 12 right now?
Because a transition
Yes,
metal.
because they are B group elements. I told that we are just focusing on A group elements now. So we will directly move to group 13. So group 13 means we are talking about this group now. So I'm going to leave this 3 to 12, those characteristics, this characteristic, 3 to 12 characteristic we are going to study later on as a B group elements. So group 13, the valence electrons will be 3. Remember, it's not 13. 13 group doesn't mean 13 valence electrons. It will be 3 because it is also called as group 3A. Then if we have group 14, valence electron will be 4. Group 15, valence electron will be 5. Group 16, valence electron 6. Group 17, valence electron 7. And group 18, valence electron 8. And when we talk about valency, this becomes +3, this becomes +-4, -3, -2, -1, and 0. So with this, what we conclude also that group 1, 2, and 13, group 1, 2, and 13, they are metals. Group 1, group 2, group 13 are metals. Group 15, group 16, group 17 are non-metals. And group 18 is a noble gas. So group 1 is called as alkali metals. Group 2 is called as alkaline earth metal. Okay. Group 13 is also metals, which is aluminum family. 14 has a mixture of non-metals and metalloids, where carbon is a non-metal, but silicon, germanium, they all are metalloids. So these are metalloids. which have both properties of metals and non-metals. Group 15, group 16 and 17, they all are non-metals. And group 18 is called as noble gas. Group 18 is called as noble gas. Okay. So till here it is clear that what denotes the group number, the element which is present in the group number, that many number of valence electrons will be present in that particular element. So let us continue with group 1A. Group 1A are called as alkali metals. So elements are lithium, sodium, potassium, rubidium, cesium, and francium. So when we talk about these elements, so now when we talk about group 1, so what will be the valence electron present in this group 1? Valence electron means outermost electron. How many outermost electron in group 1? Yes. Just now we studied that depending on the number of group, that many number of valence electron will be there. So how many electrons will be present in each atom of group 1?
1.
Yes, because if we talk about lithium, whose atomic number is 3, electronic configuration is 2, 1. Sodium, which is 11, it is 2, 8, 1. Potassium, which is 19, 2, 8, 8, 1. So if you look, all of these are having outermost electron as 1. So their valency is also going to be 1. So they will, yes, Arpita.
Can you go to the previous slide where you wrote like the group numbers
Yes,
with the
yes,
names?
yes, yes, yes. Please copy down this if you want. Please copy down this.
Not this one, the one where you wrote like
Yeah,
are the
yeah,
alkali
yeah,
metals.
yeah, yeah. Yes, done, Arpita.
Is 14 metals or non-metals? Like
14 we can write as non-metals only. Non-metals, metalloids. Actually, group 14 is a unique thing. So normally they form covalent bonding.
I'm done.
Yes.
I finished writing.
Okay. So over here talking about group 1, valence electron is 1. So valency is +1. And they are alkali metals. Now, why they are called as alkali metals? Okay, why group 1 are called as, why group 1 are called as alkali metals? The reason is because when you dissolve these metals in water, when you dissolve these metals in water, they form soluble base, which is alkali. The soluble bases are actually called as alkali. For example, lithium plus H2O will give LiOH plus hydrogen gas. So there is a formation of this soluble base. So lithium hydroxide is an alkaline solution. And yes, there is always a formation of hydrogen gas. So that is why they all are called as alkali metals. Now, what are the characteristics of these alkali metals? Characteristics. So I'm going to write characteristics over here with red. Already valence electron and valence E is written, but still I'll write it again. So what are the characteristics? The characteristics are number one, valence electron is equal to 1. Valence C is equal to +1. That is, they will lose electrons because they are metals. Then they are soft metals. They are soft metals which can be cut with a knife as well. Can be cut with knife. Then react. Very, Nafisa, yes.
They are stored in oil because they can
Yes,
react with
yes,
the
yes.
atmosphere.
Yeah, react very vigorously with air and water. So they are stored under oil or kerosene. Okay. Then another thing is they have low density. They have low density. Okay. And as you go down the group, okay, as you go
The
down the,
melting point decrease. Melting point decreases.
yeah, as you go down the group, melting point will decrease, not increase. That increase is for halogens. Down the group, melting point decreases, but reactivity increases, and also atomic radius increases. Now, what is atomic radius and reactivity increases? So let me explain you with the thing. Let's say if I have lithium, which is Z is equal to 3, sodium Z is equal to 11, and potassium Z is equal to 19. Now, when we talk about lithium, sodium, potassium, and so of course other elements, but we will be focusing on first three so that we can understand the trend. Now, lithium electronic configuration, I have lithium, the nucleus over here. It is 2, 1. 2, 1. Sodium, the nucleus, 2, 8, 1. Potassium, 2, 8, 8, 1. So 2, 8, 1, 2, 8, 8, and 1. Now, what do we mean by atomic radius? The definition of atomic radius. Atomic radius is distance from nucleus to outermost electron. So this distance, and this distance. Where is atomic radius more?
Potassium.
Exactly. So potassium, the last electron is very far from the nucleus because it is at the 4th shell. Sodium, the last electron is on the 3rd shell, and for lithium, the last electron is on the 1st shell. Now, what is the characteristic of a metal? Where will be like in which of the three the last electron can easily be lost? So distance from nucleus to outermost shell. So atomic radius,
Potassium.
yes. So since atomic radius of potassium is more, K can lose electron very easily. So if I go down the group, so compared to lithium, sodium can lose electron easily. Compared to sodium, potassium can lose electron easily. Compared to potassium, rubidium can lose electron easily. So as you go down the group in group 1, okay, as you go down the group in group 1, what happens to the reactivity? So potassium can lose electron very easily. So the trend in group 1 easily as compared to lithium and sodium. Okay, so trend in group 1 is that reactivity increases down the group. Okay, so reactivity increases down the group. So as you go down the group, the reactivity will increase, but yes, the melting point will decrease because the density also decreases. Okay, so is this group 1 very clear? Okay, now about the reactions of group 1 metals. So that also I'm going to write reactions of group 1. So group 1 metal, the first reaction, I'm just going to write a general reaction. So group 1 metal plus oxygen. Yes, Arpita.
I haven't written down the characteristics.
Okay, you guys can just take a screenshot over here. Okay, for every slide, just take a screenshot. The reason for not writing, I'm not giving you time because I need to finish some concepts, because if I give you time, then we will not have that much time. So just take a screenshot, and yes, during the time or tomorrow also you can write it in your notebook. So that can be a revision. So just take a screenshot. So I'm starting with first slide. If those who have not taken the screenshot, just take it down. So group 1 metal plus oxygen will give you metal oxide. So if you take sodium plus O2, it will give you Na2O. You have to be very sure that you are balancing the equations. Second reaction, metal plus water gives metal hydroxide plus hydrogen gas. So K plus H2O gives KOH plus H2. Hydrogen, oxygen, they all are diatomic. Then we have third one. If metal reacts with halogens. Halogens means if they react with group 17, then they form metal halides, which are salts. Example, Na plus Cl2, all halogens are diatomic, which we are going to just study in few minutes. It will give us sodium chloride. Okay. Now another very important point, all group 1 and group 2 metal compounds all group 1, so I'm talking about group 1, that is alkali metals and alkaline earth metals. All group 1 and group 2 metal compounds which are formed are white solids. Whether you take sodium oxide or lithium oxide, sodium hydroxide, sodium chloride, potassium chloride, magnesium oxide, calcium hydroxide, anything is going to be white solids. They all are going to be white solids. And when we talk about group 1 specifically, all group 1 compounds are water soluble. Not group 2 because all are not water soluble. That's why I'm specifying only with group 1. So all group 1 compounds are water soluble. So this completes for group 1. Please take a screenshot of this. Sorry. Done. Can we go ahead? Then talking about group 2. Group 2 are called as alkaline earth metals because they are present in the earth's crust. Beryllium, magnesium, calcium, strontium, and so on. So from periodic table, you can get to know. So if it is in group 2, what will be the valence electron? How many valence electron will it have? 2.
2.
Valency will be +2. Okay. So all the rest properties, like all the properties are similar to group 1 metals. So that is why we are not going to study much in detail about group 2 because the only kind of a major difference is valence electron is 2 and valency is +2. As you go down the group, reactivity increases. They also have comparatively low density, but yes, they are not that explosive, okay? Not that reactive, or we can write less reactive than group 1. Less reactive than group 1. Okay. So this was about group 2. So we are not going to do much details for group 2. So just take a screenshot of this and we'll move to the next group, which is group 17, a very crucial group, group 17. Okay, so let's go to for group 17. Group 17, also called as 7A. Whenever they ask for writing the group number, yes, Nafisa, or it is your hand which you had raised before?
It's my hand that I raised before.
Okay, fine. So yeah, group 17, whenever they ask you to write the group number, please don't write group 7. You have to write group 17. Group 17 or 7A, which is the second last column, they are called as halogens. Second last column, which are called as halogens. So halogens are group 17. They come under non-metals. The elements are fluorine, chlorine, bromine, iodine, and astatine. It's not, it's 80. Astatine, iodine, bromine, chlorine, and fluorine. Now, when we talk about these halogens, so halogens are nothing but they are group 17. So what will be the general characteristic? Yes, we know that valence electron will be 7. Valency will be -1, and they are non-metals. So non-metals means they will gain electrons. Okay, they will gain electrons. Now, another very peculiarity of these group is it's a very versatile group. Versatile group means this is the only group in the periodic table where all the 3 states of matter are available. Like for example, fluorine is a pale yellow gas. So it's a gas. Chlorine is also a greenish gas, greenish yellow gas. Bromine is reddish brown liquid, or we can write red brown liquid, red brown liquid. Iodine is a purple, a dark purple, black solid. And astatine is also black solid. So if you see gas, liquid, solid, and solid. Okay. So this is the only group where you find all the 3 states of matter together. Now, let us learn about the reactivity. And also one more very important characteristic is that halogens exist as diatomic molecule. What is diatomic molecule? Means they exist as F2, Cl2, Br2, 2 fluorine atoms together. 2 fluorine atoms together. So there will be diatomic molecules. So 2 atoms of halogen bonded with covalent bond. 2
You
atoms
need to use
of,
the characteristic that
yes, sorry.
the color becomes darker when you go down the road.
Yeah, so that is what green, red, purple, black. So it goes, so which means the density increases and also the melting point increases. So group 1, the first group and the second last group is opposite. The melting point increases down the group. So melting point increases down the group. And reactivity. What will happen to the reactivity? Will it increase or decrease? Reactivity will increase or decrease?
Okay.
Reactivity will decrease down the group. Why? Because who has more reactivity, gas or solid? Who has more kinetic energy? Samuel, who has more kinetic energy? Gas or solid? Samuel, are you there in the class? Samuel? Yes, Nafisa.
Gas is the most kind of thing.
Correct. So gas has more kinetic energy. So if you are going down, 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 and it's becoming solid, can I say the kinetic energy will decrease? So if the kinetic energy, the energy of the particle decreases, so the reactivity also decreases. So that's why I told you group 1 and group 17 goes opposite. Group 1, when you go down, reactivity will increase, and for group 17, reactivity will decrease. So reactivity will decrease down the group, and they exist as a diatomic molecule. So between two atoms of halogen, there is always a covalent bond. And another important thing which you have to remember is group 1 and group 2 metals forms ionic bonding with group 17, because one is metal, one is non-metal. There will be transfer of electrons. The metals will lose electrons and non-metals will gain electrons. So they will form ionic bonding. So this was an overall about group 17. Please take a screenshot. So let's continue ahead. Let's continue ahead with group 18. Group 18 are also called as, yes, group 18 also called as,
Noble gases.
No, is it noble gases?
yes, they are called as noble gases. Noble gases, which means they are called as inert gas. Inert gas means they will not react. So helium, neon, argon, krypton, xenon, and radon. All these elements will have valence electron. How many valence electron? If they are in group 18, valence electron will be
8.
yes, valence electron will be 8, except for helium, whose valence electron is 2, because it has only 2 electrons. That's why. Since the outermost shell is completely filled, the valency of noble gas is 0. That is, they neither gain nor lose electron. Okay, they neither gain nor lose electron. Then all noble gases, they are monoatomic. Okay, all noble gases are monoatomic. Monoatomic means they exist as a single atom. So exist as single atom. They all are gas. All are gas. So talking about helium, helium will be used in hot air balloons. Neon is used in signal boards. This neon color lights are there, so signal boards. Argon is used in light bulb filaments. Krypton is used in laser lights or car head lamps. Xenon is used in nuclear explosives. Xenon and radon is basically used. Even krypton is used in nuclear explosives. So all these are some applications of group 18. So this is about group 18. So with this, we have completed 4 groups, which you should know: group 1, group 2, group 17, and group 18. And now we will study about the characteristics of the transition elements, that is group B elements. So characteristics of transition elements. Characteristics of transition elements. So transition elements are group 3 to group 12. Okay. So we will be dividing the transition elements characteristic into two categories: physical properties and chemical properties. Physical properties, they have comparatively very high melting and boiling points. So as compared to group 1 and group 2, or as compared to other metals, they have high melting and boiling point. Second, a very high density. The second physical property, very high density. Third one, very good electrical conductivity. So we know that metals have good electrical conductivity. Fourth one, good electrical conductivity and good ductility and malleability. So these are some physical properties of transition elements, because in the papers, like specially structured paper, they do ask mention physical properties. Yeah, that is Nafisa, that is for chemical properties. Oxidation states are chemical properties. If they ask you to just write general properties, you can mix physical and chemical both. But as I told you that for some papers, like in the past paper, they have specifically asked physical or chemical properties. So you need to understand where is the bifurcation. So chemical properties, number one, they have variable oxidation states. Now, what do we mean by variable oxidation state? Now, when we talk about group 1, they have a specific oxidation state that is +1, means valency is +1 for all group 1 elements. For group 2, it is +2. So means it is specific. But when we talk about these transition elements which are in middle, and all these transition elements are metals actually. So variable oxidation state, example, iron, okay, Fe. It exists as Fe2 plus also, it exists as Fe3 plus also. Copper, Cu, exists as Cu plus as well as Cu2 plus. So there are other elements also which can exist in more than 2 oxidation state. Second one, they form colored compounds. Example, KMNO4, potassium permanganate, where manganese is a transition metal. It is purple color. If I have K2Cr2O7, chromium is a transition element. It's orange color. Copper sulfate crystals, blue color. Okay. Third one, they act as a catalyst. Now, what are catalysts? Catalysts are those substances which increases or speeds up the rate of reaction. Okay, which speeds up the rate of reaction, means the reaction will become faster without being consumed, without itself consumed. So more about catalyst, you will be studying in your later part of year 10, where there is a chapter which is called as rates of reaction. So over there in more detail, you will be studying about that. So, okay, act as a catalyst. Example, powdered iron act as catalyst in manufacture of ammonia. So manufacture of ammonia, the process name is Haber's process. So this is just one example to make you understand, and that reaction I'm writing it over here, that from nitrogen and hydrogen, reversible reaction, you are going to write Fe. So whatever catalyst you are going to use, you will write it on the top of arrow, which is going to form ammonia gas. Okay, so the reaction for this is over here. So this completes the overall group properties of periodic table. So when we meet in the next class, that is on Tuesday, we are going to study about the certain trends in the period, and then we will be solving some questions based on this. So please just take a screenshot of this, okay? And just check if you have any doubts. Please check if you have any doubts. So any doubts, Arpita,
No.
Nafisa? Yes, Arpita, Nafisa, Samuel. Yes, Samuel, Alishba, Amishi, are you there in the class? I am getting no response.
Yeah,
No,
miss.
miss.
Yeah, Amishi, you have any doubt?
No, miss, I don't.
Okay, Nesden.
I have one doubt about how the catalyst speeds up the reaction without itself being consumed.
See, basically what happens is it is not that it will not be consumed completely, but the activity will be reduced. Like for example, if you talk about the dry cell, the cell or the battery which we put it in the remote controls, maybe AC or TV. Now you cannot actually see that the dry cell or the cell size is not diminished, but can I say the power gets reduced?
Yes, miss.
So it exactly happens over here. The particles will loses its energy. So but the overall, what you can say, the overall mass does not change. The activity gets reduced. So you will get back your catalyst. You can reuse it, but yes, at one point of time you have to change it because the activity of that catalyst is over. So you have to you like throw that catalyst and you have to add fresh catalyst to that. Okay, Neston.
Yes, miss.
Yeah, so uh, this is something about the overall periodic table, and yes, as I told you that the questions in structured paper as well as MCQ, both periodic table, the question comes, so that questions We will be solving it in our next lecture, that's on Tuesday, and also a small concept of trends across the period which is left. We will be doing that. So with this, we'll end up the session. Thank you very much. Sending you the notes and recording by evening. And we will meet again on Tuesday, same time at 11 a.m. Till then, bye-bye. Take care and have a nice day.
Thank you.
Bye, miss. Thanks so much.
Bye-bye.